well, it's one after, so why don't we go ahead and get started. This talk has a title which I've forgotten, but it's a live demo of putting together a container starting with absolutely nothing to try and demonstrate that it's not actually all that special. And I am going to silence my phone and code. Jeez. We're gonna quit. Where is it? We're gonna quit VS Code so it doesn't keep asking to update. Hopefully this is all sufficiently amusing for you. Okay. Anyway, so I hope that all makes sense. And it is supposed to be interactive, so feel free to yell out questions at any time, and we can stop and talk about cool stuff. So right now we're in an empty directory, right? So I've got a terminal here. I hope people like terminal because there's going to be a lot of it. And where should we put it? Let's make a subdirectory to put the actual image in case we want to put some other stuff around. So we're just going to make an image, or make a directory called image. We'll go in there. And then, oops. cd image. So let's containerize bash, right? Just because that's a program that people know what it is. So we've got our user bin bash, right? It's just program. We can do right. So we can run echo hello. What do we need to run bash? Right. Well, first we need bash, right? So let's make a directory to put it in. We'll just put it in /bin, and then we can do cp. I think we want pl. You know what? Let me grab my notes. Sorry, real quick. I don't know that. Okay.
Right there?
Never mind. I didn't copy them. I did not copy them to that other computer. But we'll be good. Anyway, so we need bash, right? If we're going to run bash, we need bash. So let's start with that. So we're going to do user bin bash, and we'll put it in the container, right? So now we have a container, and it has, or we have a container image, and it has exactly one program in it. Does it work, right? So we can try with chrun. We're going to give the path to the container right here, which is dot. It's the current directory, and then let's try bash. And so we get an error, right? That's what we wanted. Doesn't like that there's no /dev in the image, right? And this is because this is not 100% fundamental to containerization, but something that Charlie Cloud does is it bind mounts the host /dev into the container, right? So we need a destination for that. Though you know what? This might be a good time to use the right fake, right? This overlays a tempfs on top of the image, so it can actually create things within the image at runtime. This Charlie Cloud containers are read-only by default. If they're writable, okay, so I guess some bind mounts it's smart enough to create the directory, and this one is fundamental enough that it's not, but we can just make that directory, right? So we'll make a dev directory. We'll try again. This will be an iterative process, right? And now, oh, come on, I just made it. Sorry?
I think the last command, you didn't do the right fake.
Right, but it should have that. Why is it? But I created the directory, though, so the right fake shouldn't be needed anymore. But I'm not in readpr.ch. You know what? I wonder if it doesn't like the dot. So we're going to say var temp all you need, and then image. Okay, so now we're making progress. It also wants proc. I'm guessing it probably wants etc. And you can see that we're sort of bringing in the basic directories that a Linux distribution expects, right? So we can do, okay, we want sys. Etc password, okay, so, and this is, so interesting thing about the Linux kernel that I learned recently is that the Linux kernel does not care about usernames at all, right? That's completely a user space concept. It just does the numeric IDs, right? This file here, etc password, is how you map user IDs to usernames. Charlie Cloud builds an etc password and binds it into the image so that your username looks correct, right? So we need a destination for that, right? And we're also going to need group, right? That's the same deal for group IDs. So let's try that. Okay, so now it wants temp. And you can also see the nice colors for error messages. It's very red, meaning that it's a serious error and you're stuck. We can do make dir temp. Okay, so now we get to an error that's actually confusing, right? So I just put bash in there, right? It says no such file or directory. Okay, maybe something's wrong with my path. So let's give the complete path to it, right? Still doesn't like it. Did we typo that? No, it's right there. So the problem is shared libraries, right? So if we do LDD, and I'm going to look in on the host side, right? So it's got some shared libraries. And something I've found amusing is that there seems to be this very slow back and forth on whether shared library-like things are good or bad, right? You know, long time ago, there was no shared libraries. Everything was statically linked. You copy all the libraries into your executable. People were like, oh, we don't like that. Now we have shared libraries. And now things like Go and perhaps Rust really like static linking again. Containers, it's sort of similar, right? In the sense that you copy all this stuff into the container, you know, dynamically link stuff into the container, GPUs and things aside. Anyway, so we have three libraries here that we actually care about, right? And it's these three. This is secretly not a shared library. It's some sort of kernel thing that appears to be a shared library to the executable. So we're like, okay, well, let's put those libraries into the image, right? So we're going to do make dir lib, arch64, Linux, GNU, right? And now we can copy these. Okay, and what is the PL about? So if we, okay, so I'll copy that. If we look at what the library actually is on the host system, it's going to be a symlink, right? This has to do with how shared libraries are versioned. We want the actual shared library, not just a dangling symlink. And that's the purpose of the PL. We want to follow the symlink and copy the actual file in, right? So we can do PL this, and then inside the image, we're going to put it in the arc. Didn't I just make that? Okay. Lib. Okay, so I typoed something. Oh, it gave me an error message and I didn't notice. See, it's not bright red, so I missed it. Anyway, but we can fix that. Come on, I know you're there. Okay, so then here, what we want is make dir-p, right? And that makes the parent directories as well. Okay, so now we'll copy the right? CP. Huh. Oh, I controlled C it. Okay. Never mind. Right. So now we can copy it into libarch64 GNU, right? And there were some others. Right. So we also want so we did that one. So we want libc. And we also want, that one just goes in lib. Paths on shared libraries can be fiddly, so they probably don't have to go exactly where they are here, but I'm not smart enough to figure out the destinations live, so I'm just going to put them in the same places. Right, so we can do that one. We do that one. LD Linux. That one goes in lib, right? So now if we look at our image, now we have, right, this is starting to look more normal, right? You know, we have one program, we have bash, that's group and password. They're just empty files for the time being because they're targets for bind mount. And then in lib, now we have those 3 libs, right? So let's see if it works. Okay, we're going to do chrun. Okay, there we go. All you need, bin bash. And hey, look. So now we're in a container now. So what's the first command you always execute when you're in a shell? It's ls, right? Okay, well, we don't have any ls. So literally all we have is bash. So there's no programs that we can execute, but we can use bash built-ins, right? So we could do something like echo star, right? Or we could do echo bin star. And the reason this works is that echo is a bash built-in. Bash is doing the wildcard expansion. So we can ls that way. That's a little awkward. Let's see how hard it would be to get an actual ls. Oh, I know what I was going to do. Right, so we're still in the container, right? Let's bring up another terminal, and we're going to make it big. And if it's not exactly the same size, I will be bothered. So let's do that. Okay, so this is a terminal on my Mac. We need to get into the virtual machine. All right, so now we're on my Linux virtual machine. Let's go to the image right here. Okay, so I think I have ls, you know, and I'm gonna start. So /bin or /user and / are now the same thing. It used to be /user was a different file system, and et cetera, et cetera. Now they tend to be the same thing, right? So if we do ls-l, I think, where would it be? Yeah, so bin is just symlinked to user bin now on most Linuxes, but that means that I can stop typing user bin. All right, so if we do LDD of bin ls, right, we've got some shared libraries for that too. And this is probably GNU ls, just as for interest. Okay, so previously we did these two. So we need ls and then these other libraries, right? So we'll do a cp-pl of bin ls. We'll put that in bin, and then we have 2 libraries that go in libarch64. All right, so we'll do pl. This one, and this one, those go in libarch64. Okay, and then, so some basic debugging tools might be useful. You can see how hard that would be. But specifically, what libraries does LDD need, right? Oh, it's not a dynamic executable, which makes sense because if your shared libraries are broken, you want to be able to debug it, right? So that's thoughtful on the part of the Debian people. But let's put that in the image, and that'll help us debug things, possibly. Right. So we'll put that in the image. So now if we review, right, here's our standard directories. We have 3 programs, bash, LDD, and ls. These are the libraries. These are more libraries. Okay. So let's go back into the image, right? So now we're in the container. We can try ls again, right? And okay, so this is a useful error message. It tells us can't get that shared library. If we're lucky, we can even do an LDD. It can tell us what's missing in this way too, right? So libpcre, that one's not found. So now we need to fix that. Oh, and I already have a container. Okay, we did a little switcheroo. If you were here yesterday, you might have heard me talking about how containers are just directories. The directory is live in both directions, right? So we have a running container right here, and then on this side, we have just a shell on the host. So we can fix it live, right? So we need libpcre and, sorry, I forgot where exactly it was. Okay, so that one's libarch64 also, right? pcre, oh boy, 2-8. .so.0 is the one it wants. So now we'll put that on libarch64. So this container is still running, and now this works, right? So it's not very nicely colored because it's a very basic thing, but we don't have any not founds anymore, and now we can actually see what's in the container, right? And we could do, you know what, let's, oh, it doesn't even clear the screen. This, just, it can be amusing working in a really bare bones environment, but we can do a ls-lr of / right? Because it's, holy crap. Oh, I know. There's a bunch of bind modded stuff, right? It's much longer because it's bringing in stuff from the host. So is this actually feasible to look through? Oh boy. Oh, -t.
If you use the tree command instead of ls.
Oh, but we don't have tree. That's a good idea. But we can go piece by piece, right? So here's our bin, and then if we did, or that's the /, and now if we did, right? So emphasizing that this is now the root because we're in a container. If we do /bin, you know, here's our program, and we could go in there. Something that I think is kind of neat that Charlie Cloud does by default is that temp is actually shared with the host, and that I think is a quality of life thing that's kind of nice. It means that you don't have to do anything to start sharing files, and if you like have multiple ch runs and it starts to put stuff in t8 and temp, it'll pick it up on in the next one and stuff like that. You can turn that off if you don't like it. If we look in, okay, so we're not going to have, do we have cat? Cat's not found. Okay. Oh, the question. Yeah.
So the nobody and no group is replacing anything that's owned by root typically, or not really?
Okay, yeah, so that's actually pretty interesting. So we don't have cat. So I'll get into this is a really interesting question. I'll get into detail sometime this morning. But what you're seeing is the user ID mapping inside the unprivileged user namespace, right? So got nothing. Okay, so I'm still user 1001 inside the user namespace. So the map is an identity map, right? User 1001 is the only user that's actually mapped, and so everybody else shows up as nobody, right? So if we did /dev, okay.
But the password file and the group file don't have the user UIDs and the GIDs that are in the container now. Because you maintained the UID and GID when you did the copy, right? Like that.
Right.
So they're not resolved within the Etsy password. Etsy group. Seems like that would be the reason.
So that stacks on top a little bit, right? That's a good follow-up. We'll get to that. What do we want? So something that's interesting is that, so here's the dev that we made, right? That's owned by us, right? You can compare to /bin. Both of these are owned by us, right? If you look in here, you see bin shows up as me, dev shows up as nobody. And you're like, well, why is that? It's because of the bind mount. It's not the dev that we created. That's just a mount point. What it is this one, right? Root is not mapped, so that shows up as nobody. It's the same deal with no group. And then Etsy password, that's what I was trying to show when I was trying to figure out if there's a cat. There's probably some way to convince Bash to show us the file, but I'd have to think harder about that. But what we do have is, so like you notice if we look in temp, one of the files is the chrun password.stuff, right? This is actually the password file that's inside the container. And if we put in mount or something like that, I could show that, but the contents of this file, so it's /temp. This is the same file, and it is bind mounted into the container. Why there's not a corresponding group file is a little confusing to me, but yeah. Anyway, so this is built on the fly, right? And it always does root. It does nobody so that shows up with a username, right? So from the kernel's perspective, what it's thinking about is this ID 65534, right? Me, I'm user 1000. I guess I'm 1 unit less special than I thought I was. So John's question about Etsy password, the fact that it's nobody is libc looking up user ID 65534 in Etsy password. And in fact,
It is in the password file as nobody.
yes, it is in the password as nobody. We could do, like we can even edit this file. Right, and now, what were we? Oh, / we wanted ls.
Yeah.
Still shows up as nobody.
It might be cached.
Yeah. Anyway, that's what's going on. Does that answer the questions?
Yeah.
Okay. So now we have a working yet extremely basic container. And we've, I go until 10? Yep. Okay, thank you. So now we've earned, or I've earned my fat HPC architect salary by creating this really useful container. So I want to share it, right? I want to show it to John so he gives me more money.
So that we can put more in.
Yeah. All right. So right now we just have a container on disk, right? We want to put it up to a container registry. We happen to have a container registry running right here, and this is actually kind of neat. We use this for testing. There's just there's an image on Docker Hub that runs a basic registry. So I have that running. There's a good reason that it's in Docker rather than Charlie Cloud. I don't remember what that reason was, though, but it's handy to have Docker around even if you are a Charlie Cloud person. Anyway, so this registry is running right here. Somehow we need to put a file there to it. So, okay. So let's start from scratch because my chimage storage directory is really messy at the moment. So we're just going to clear it out. Right, so we can do chimage list, and there's nothing in it, right? The output is some initialization stuff, but if we did this, okay, nothing. What we can do is we can do chimage import image, right? And we can provide a name for it. Right, it doesn't have to be called image. That's the default. You look like you're about to ask a question. No, you're just looking tuple. Sorry, say again.
Is it like the prompt seems to indicate that you're already inside the image directory?
Oh, yes. Good catch. So, fellow in the audience found a typo. Hopefully that works. Okay, so now if we do image list, we now have an image called John. Could even run it if we wanted, right? So one of the things chrun can do is find an image in the chimage storage and run it, right? So we could actually run it by name. Could do chrun John. We're in the same place. This is a copy. This is not the same image, but it's there. What else can we, oh, okay, we could do image build cache. So it's actually, let's do, it can tell us more. This is just cool. Like, I think our Git-based build cache is just really cool. It's also, I guess, kind of verbose. Right. Okay, so there's our storage directory. Tree, that's what I'm looking for. I want the tree view. Oh boy. Okay, -- tree. Okay, well, it's a very complicated tree, but so the bottom is always the empty image, and then from that we derived an imported image. So it's got this pseudo instruction called import. And if we wanted to be more verbose about it, we can give it a -v, and now it's showing us some hex numbers. So one of the cool things I think about our build cache, this is the git commit hash, right? that is not the right identifier for our purposes. So we also store what we call a state ID in I think it's in the git commit message, right? And you can read the paper if you want to know exactly how this is computed, but this is a different identifier. This is derived from the instruction, the Dockerfile instruction, along with all its history. So it's a hash of this one, which is a constant because that's the empty image, and then import John, right? If you look closely, this may be familiar to a very small number of people. Anyway, so that's the git cache. What we want to do is push it somewhere, right? So list, we can do chimage push. And fortunately, I still have the command from when I did it earlier. So what's going on here? Push is the push command for chimage. This registry has a self-signed certificate, and I didn't want to bother setting up trust for it, so I can do TLS no verify. That's trust anything. This is the source image. And something that we can do that I don't see Docker and Podman doing is that you do not need to add a tag in order to push an image somewhere, right? I can just say push it to this destination, which seems tidier to me. Anyway, so we can do that. And you saw some log stuff jump up, right? So we've spoken to the registry, and it's like, hey, you need to authorize. This is pretty verbose. But here it's like, okay, what's your username? Well, the username happens to be Charlie, and it has a password which is super, super secret. And I pushed it, right? So here's the incomprehensible logs. I just don't know it. They're comprehensible, right? And now Charlie Cloud is doing the pushing, right? So there's some distinction between gathering and preparing, which I could look up. There's the metadata, this is the JSON blobs that's starting to upload, right? So we're only pushing one layer, right? At the moment, Charlie Cloud just pushes a single layer. We'll fix that eventually. But it's like, hey, do you already have this layer? No, it doesn't because it's got nothing. Okay, we're going to upload it. If you have a bigger image, it'll actually give you a progress meter here, which I think is really neat. Do you have this config? No, we're going to upload it. And now we're going to upload the manifest. And then something gets cleaned up. And now we're done. Question?
If you push, you modify the image and you push again, it's overwriting the previous one, or it's using the checksum to store them?
So the registry will get a new image because it'll be a new tarball with a new hash. Interestingly, it will confuse the Charlie Cloud build cache because we look at the text of the import command. We don't scan the whole directory, and that's just that's an optimization. We're guessing that is better than a slower import. Does that make sense?
Related question: the ID that you calculate is based on that specific layer, or also layers that you import?
It's on the
Like if something changes in an imported layer, will your ID change or not?
It will not change. And I mean, we're open to, we could add an option to change it, but right now what it's the hash of is this. So that's the ancestor, immediate ancestor. If it had more ancestors, this one right here would include any ancestors beyond that. It's the the digest of this appended with this. Approximately. There's some details. So if we imported a different image and also called it John, it would get the same hash. And that's a documentation. That's in the documentation, but that's a risk. Okay, so we put it in the registry. So we could pretend that now we want to get it back. And to prove it works, I'm gonna dump my storage directory. So now it's empty again. But we can pull it. We can do chimage. You know what we can do? I'll show this too. So we can do, I think this is it. Chimage username. X. And now if we do, I think this, if I remember the names of those environment variables right, this will work. And we can pull it. You know, it's localhost 5000. Image name is John. Charlie Cloud doesn't care a whole lot if the image has a tag after the colon. I think it may have put on latest. We'll find out. Well, okay, so it will now infer the destination name if we don't give it. Get failed. Oh, right, so I didn't say TLS no verify. Because it's complaining that the certificate is bogus, self-signed certificate. And because I have some debug settings on by environment variable, and that's why it gives me this abbreviated trace of the failure. That's really useful for debugging. Unauthorized. Latest. So it appended a latest there. You know, I wonder if it got confused. Okay. So we're going to back up just a little bit. OCI really likes images to have tags. So I think that we got our wires crossed with the registry. So we're just going to import it again. Push. And then this time, we'll give it a tag when we push it.
It's pull instead of push.
Oh. That's actually very handy to have the typos pointed out right away. No, I'm serious. That's great. Keep doing that, please. Can't push. Oh, right. Okay. It's still called John here. Okay, so we put it back in the registry. Now we can do our chimage reset. And now we're going to try our pull. So now this should work. Okay, yeah, so this is something that we do. There's a kind of elaborate authentication dance when you talk to OCI registry, and it's in the style that's kind of fashionable where there's no asking permission, there's asking for forgiveness, right? So we've said, hey, I want to do this, and it's like, no, here's how you can authenticate, and then you authenticate and do the thing again. Which I find a little confusing, but that's what it is, and it gives a hint, right? So because push is almost always authenticated, it infers this auth. Pull is often anonymous, so it doesn't infer it. And this gets to like I was talking yesterday about the explicit versus implicit. previously we were trying to guess if you needed auth, and it got really confusing. So we just gave up, and now you can say whether you want to authenticate or not. Which I think it's also more clear for a user. You can say, I want to be anonymous or I want to be authenticated, and you can clearly choose what you want. Architecture. Oh, here we go. Okay, so this is another interesting thing. So architecture, images have an architecture set. Sometimes, right? So saying, oh, this image is architecture unaware, because it doesn't actually have an architecture tag when I pushed it. It does not, it's not willing to guess on the architecture because I'm on ARM64. If I was on x86, it's willing to just guess and be like, okay, well, I'm going to guess that you're on x86 because that's so common. So what we need to do is give it, tell it which architecture we want. And in this case, the image doesn't have an architecture set, so I'm going to say, I'm going to take anything. Just give me that image, right? So now I pulled it down, right? Downloaded the manifest, downloaded the config, we downloaded the layer. If we look up here, we'll see it's the same hash. CH image list. Okay. Oh, yeah, thank you.
So how much matching will you do with like the architecture and families? I know Slack has this ArchSpec library that it used to try and do that. So if you had like a very optimized builder image and you didn't have the corresponding architecture, if you had a more generalized image that you uploaded, like is there any sort of resolution for like the sub-family specialization processor?
Yeah, so the question is, when it asks for an architecture, is it smart or dumb? And the answer is that it's dumb. This is the sum total of the architecture information it's passing. No, all it knows is it wants an ARM64 image. And all these details of the microarchitecture, OCI has no clue, right? And that's actually one of the flaws that I see with OCI, that there's not a way to express architecture more carefully. And the ArchSpec library is, to me, seems very much the way to go. And my hope is to somehow make the registry smarter about that type of thing.
I guess you could kind of use the tag of the image maybe.
And that's what people do. People put the architectures in the tag or the image name or something like that. Though the way that they encode it is they give the cluster name, because users tend not to know all those details.
But I see ARM64 V8, so let's say it was like x86 64 V3, you could still get AVX maybe? Would it really just be like, I have no idea?
You would hope. So the question is, there is a variant here. It's V8. Are you able to does x86 have variants to get some flavor of like ABX? The answer is no. This is something I find really weird about OCI as well, that the architecture is a tuple. It's the architecture and the variant. The variants really don't tell you much. So like, I think literally the only variant for ARM64 is V8. And x86 has no variants. Okay, so then I can run this image. It's not called John anymore. It's called this long thing here because I didn't give it a nicer destination, right? But we can run it, and we're right here, right? So we've pushed it to registry. We've pulled it back, and it's back, right? Now you might say, well, hey, don't want to only use Charlie Cloud. So we should be able to also Docker pull it, right? Can we do Docker pull? And this might be more exciting. We'll see. Okay, and Docker, so Docker likes to build a login credentials file. CHMH tries to be stateless, so we don't have this separate login step. If you want to save your credentials, you can use those environment variables that I had showed either. We can do Docker login, 5,000. Username is Charlie, password is super secret. And you saw there was some chatter from the register as well, registry. Okay, now maybe we can pull it. Okay, and then if we do, I think it's Docker images. Oh boy, I did not clear this out. But here it is, right? And we should, hopefully we can also run it. So if we do Docker run -it, oh, what was it called? Maybe it's still, oh, yep, there we go. It's in the clipboard. Is this how that works for Docker? Is it me or are these two strings equal? Does that work? Can we just tell it to YOLO? I haven't seen this error before. Does anybody know Docker well enough to convince it that those equal strings are actually equal? Let's try this. Oh, it has like insecure registry. Legacy common name. I think I can do maybe image inspect. What I'm trying to do, oh, I know how to do this. Okay. We'll take a detour in just a minute. Architecture, ARM64, V8, OS, Linux. What I was looking for is there like some special character that found its way into there? But if we, so let's go into the, we'll take a digression here. And we look into the, yep, okay, so this is the Charlie Cloud storage directory, right? This is our internal storage. It's not documented, right? So you should, or it's not documented. It could be documented in a sense of here are the internals. So users shouldn't rely on the structure here, but it is designed to be straightforward to look around in the explicit versus implicit principle, right? So there's several directories. I think this is really fun. So like if we look and say BU cache, this is a Git repository. This is our build cache. BU large is for large. So we have something vaguely similar to what is it? Git LFS, large file storage. We have something vaguely similar to that. Right now it's turned off, but that's what the BU large directory is about. DL cache is what I wanted to show right now. So if you were here yesterday, I talked about how registries just contain files. And so DL cache is those files after they're downloaded from the registry. And then if you want to pull the image again, it doesn't have to talk to the registry. So like, I think, so there's these two manifests right here. We have the manifest list, sometimes called a fat manifest, and a skinny manifest, sometimes called a manifest. I believe, okay, so those are identical. And if you were here yesterday, I complained about how sometimes what you put in the accept header to the request to the registry is not the type of file that you get back. So when we asked for a fat manifest, there isn't one. And so it's like, here, have a skinny manifest instead. Which is, I would much rather I get a 406 saying that I can't give you that type of thing. But that's why these two files are identical. If it was a multi-architecture image, then it would have a fat manifest, and the fat manifest lists the skinny manifests, which are the architecture specific, right? But if we did, we can look at them. And JQ-C just says, give me it in color, right? So this is what an OCI manifest looks like. And notably, images also have a config, right? So that's what this is. Say it says it's a config. It's 503 bytes long, and here's the digest, right? So we can remember it starts with CEA0. So then C0EA, right? So this is the config for that image, right? And this one says diff IDs. Oh, and this gets to the differences in the hashes, right? So these are the layers, right? It says we have a layer with a hash starting 41FA. And we do not. But if you look in the manifest, it also lists the layers. This is the same layer, but it's a different thing that's hashed, right? So that one is 48C7. Okay, so that's this file, right? So this is the tarball containing the actual layer there. And I see we have 5 minutes. So I think at this point, I'll just argue that you should take my word for it that Docker could in fact run this if we convince it that those architectures are actually the same. What questions do folks have? Yes?
Does it actually fixed, or can you move it in a place that you want? Because normally when I run on a site, I prefer to have everything in a tree so that I don't voice another. Well,
Yeah, you can put it wherever you want. There's an environment variable, and it can go wherever you want. File system is relevant. So like on HPC systems, your tempfs will be fast, or if you have like a local NVMe, that will be fast. Neither of those are persistent. You'll have an NFS or a Lustre that is persistent. Those are slow. At some point, I would like to be able to split the storage directory and optimize so some parts of the storage directory care more about speed, or some parts of the storage directory, all of it cares about speed. Some parts care more about persistence than others. So I'd like to be able to only put the persistent parts on the slow file system, but we can't do that right now. So yeah, you just set CH image storage. You look questioning.
Yeah. So I've seen, I think it's apptainer uses overlay FS somewhere in the image creation process, and I just kind of trying to reason about, why that's used, or like this Charlie Cloud or something similar, or is it just to make creating the image faster for a large set of files, or because this is like a relatively small container, I'm just trying to think about the steps of what the image creation process is and
Right.
creating the intermediate file system for progressive.
Yeah. So the purpose of the overlay FS, the overlay FS and the layers are complementary, right? The way that like Docker Podman, I don't know if Apptainer does this actually, but the way they do the Dockerfiles is they'll lay down an overlay FS, or they'll create an empty temp FS, put it on top of the previous state with overlay FS, run the instruction, tar up the contents of that layer, put the next temp FS on and keep going. And then when you are setting up the image to run, you sort of reverse that process, right? Each layer gets its own overlay FS, and you untar and onto each layer onto the overlay FS. And that means if you have a lot of layers and you want to do a file system operation, it could be going down through a lot of overlay FSs, which is one of the motivations for the Git-based cache, which uses a flat file system, and it uses Git to move around the state. And I think probably I should be done. Let me know what other questions you have, and I think Silva's up next. Okay, good.
If you do have more questions, the last Charlie Cloud session of today, which is Live, Laugh, Love Containers.
Oh yeah.
You can ask me all of your questions because that's what it's locked out for.
Yeah, so we just have office hours, and they're called Live, Laugh, Love Containers at some time. Thanks.